Hi, I'm Shelley Alford, and we'll be together today for our first time on the recording side. I posted the last session, and this time I'm recording a session from Mastering the Basic Math Facts in Addition and Subtraction, and we're going to be working on chapters 2 and chapter 3 today. This is plus 1 and plus 2, and then we're going to move into plus 0. So today we're working still from the book, and I'm working on getting the video right. Basic Math Facts, Addition and Subtraction. It looks a little different from the multiplication and division book that Michael's going to be presenting to you. And today we're going to start on chapter 2, and again that's plus 1 and plus 2. And our goal for today, I guess I should say the goals, is to provide the students with multiple strategies to quickly and efficiently find sums and differences. And one of the reasons we want that to be quickly and efficiently, because once they get that, we don't have to worry about them struggling with that when they're trying to do more advanced work within the math genre. This focus on strategies serves to expand their understanding of numbers and properties. That properties piece, you're going to hear that again and again and again. All right, moving from counting all to plus 1 and plus 2. So every time they have a bunch of something, they're not having to count each one individually. They can just pick a number, the highest number, the largest quantity, and then add to that, and that makes a much more fluent mathematician. Building on students' understanding of counting and their previous experiences with number lines, which we'll be talking about my handy dandy number line that has a nice glare to it as well, which I'm finding out. Building on their experiences with number lines, the transition from counting all to beginning with one addend and counting on or back for subtraction, and find the sum or difference. So those are our goals. And in this book, the big ideas is part of the biggest focus on here. And I'm like Michael, he had said that in the beginning, that he really enjoyed the focus in the book, and I agree with him completely on that. When we're talking about the big ideas, the sum, when 1 is added to the quantity, is the next counting number. When we can get kids to understand that, it becomes very, very, very evident that their fluency becomes much better. Our number system is a system of patterns. When they can start to identify those patterns, it changes them as mathematicians. Addition is a joining or combining process. When we can get them to understand that when we're adding, we're joining things or we're combining things, and subtraction is a separation or a comparison of things. The order of the addends does not change the sum, that commutative property. Unfortunately, when we don't understand the commutative property, it does make a big deal when they get into algebra. And when they get into those higher math skills, it makes it so difficult for them when they didn't get that foundational understanding of the commutative property. And our kindergartners can definitely get that commutative property understanding and can call it that at a later time in kindergarten. Do I expect everybody to say, in the 4th week of school, hey, we're going to talk to commutative property? Probably not. But can you still call it that? Absolutely. But you're going to add on those additional words that make it make sense. All right. Addition and subtraction are inverse processes. Will we call it an inverse process? Yes. Will we add that additional definition that goes along with it that makes them understand what that means? Absolutely. And are we going to show it to them? You bet we are. Oh, my picture's in the way. I'm sorry. Let me move me over here. I'll be moving me throughout the presentation, obviously. All right. The sum when 1 is added to a quantity is the next counting number. We're going to go through each of these big ideas because I think this is the foundation of why we're doing what we're doing through this PD. And face-to-face, this is so much easier. I'm with Michael on what he said during the introduction video. When you're face-to-face, you're able to do that discourse back and forth and have that conversation. I'm going to try my very best to make sure you don't want to, you know, poke your eye out with a stick. But the reason I want to go through each of the big ideas is when we're talking about the activities later on today, then the big ideas are what we want to focus on during those activities. So the number lines provide a helpful visual for recognizing this big idea. The sum when one is added to a quantity is the next counting number. So when we're talking about that, and we have that number line where we're showing our Wonder Nuggets, you know, when you start at 5 and you just want one more, it is that very next number. And they have that time to do that and experiences with it, and they touch it and they do it and they continue to do it and they do it again and they do it again and they do it again. That helps them understand, well, every single time I add 1, it's just that next number. Every single time I add 1, it is the next number. No matter where I am on that number line, every time I add 1, it is that next number. When transitioning to subtractions, students connect this idea to counting backwards. Now I'm going to go opposite on the number line. Okay, to counting backwards or moving from right to left on the number line. Now, when we're moving right to left on the number line, that's a confusing thing for our little people. Now, one of the things that is incredibly important to understand about what we're talking about, all of the big ideas today, one of the prerequisite skills for our little ones, especially our youngest ones, is that they have to be able to confidently and fluently count from 1 to 12 without assistance. If they pause at 9, this is going to be a concept that is going to be very, very difficult for them. So you want to make sure you're working with these concepts with those little ones that can actually count from 1 to 12 forward and backward without assistance and independently. So if they pause at a number and they need someone to get them to that next number, we want to get them fluent from 1 to 12 before we try to get them to do +1, +2 numbers. Okay, our number system is a system of patterns. Now this is huge because once we understand what those patterns look like, it completely changes, I said that earlier, it changes our thought process as a mathematician. Noticing that adding 1 or 2 or subtracting 1 or 2 is simply moving 1 or 2 places in our counting sequence gives order to the math facts. Once we know what the order is and once we're able to make sense of that order, it changes everything we have previously done in math to make things that never made sense before make sense now. Seeing this on a number line or numbers chart and connecting the idea to their counting experiences helps students recognize the predictability of math facts. Math is truly not a mystery once you understand the patterns. Once you understand the facts and the patterns together, that makes the facts make sense. So once we get them there, then it becomes oh, well, that's easy. Well, yes, it is. Addition is a joining or combining process. When addition is the act of combining parts to make a whole. When we really get them to understand that once we take this piece and once we take this piece and we put them together and we're making a whole of something, that translates to that fractional thinking later on. If we don't really lay that foundation early, then that's when it hurts later on. So right now, we are truly laying a foundation for that later thinking. Okay, so combining parts to make a whole. 6 + 1 represents joining 6 objects and 1 object to find the quantity of a new set. So if I have 6, how many do I have? I have 3 and 3. So I have 6. I have 6 pencils right here. Where do I have them? I have them right here. And I'm bringing 1 more in. And this helps students understand that the reasonableness of their answer, they get to see the reasonableness of their answer. Because if they answered 22, and then you say, okay, we'll check. And they say 1, 2, 3, 4, 5, oh, 22 is not going to be really close to this. 6, oh, it's 7. Okay, then they can check the reasonableness of their answer. Subtraction is a separation or a comparison process. When we subtract, we are separating objects from a whole set. We're taking it away or comparing sets of objects to find the difference. The expression 6 minus 1 might represent 1 apple being removed from a basket, or 6 apples, a basket of 6 apples, or it might represent a comparison between a set of 6 yellow apples and 1 red apple, to find out how many more or less are in one set. So are there more yellow apples or are there more red apples? And so there's, a comparison that way. And when focusing on math facts, this understanding helps students assess the reasonableness of their answers again. Now, those two differences in seeing, all of the apples are the same and seeing that they're different and they can compare the two, that tends to take a little bit longer for some to get to where they own it. The order of the addends does not change the sum, the commutative property. The commutative property is beyond important in the early grades because, well, whether students are visualizing 5 balloons added to 1 balloon or 1 balloon added to 5 balloons, they will notice the sum is the same. Hopefully they notice that. Okay, this knowledge immediately simplifies math fact mastery. Okay, they end up having to memorize or know or recall or own half the number of facts, because if they know 3 plus 1, what else do they know? They also know 1 plus 3. So if they know that and they have commutative property knowledge, they absolutely know that, then they don't have to worry about memorizing another set of facts. They know what the other one is because they don't have to worry about, oh, I have to know the other one, because the order doesn't matter as long as they see, or as long as they know that commutative property. Anytime students see 1 or 2 in an addend, they learn to start with the larger addend and then simply add 1 or 2. Now, is this a natural thing that happens with students? No, it's something we have to really guide them through and successfully, hopefully successfully, we make the suggestion to them and then they start practicing that and then they do it and they do it and they do it, and then it just becomes a natural practice for them. Addition and subtraction are inverse processes. Now, and I'm going to put a disclaimer before I go into this big idea, because I'm not telling you things you don't already know, and I know that because if you're in education, these are all pieces to the puzzle that we already know. But when we're talking about breaking these up into big ideas, sometimes we don't think about all of the little pieces that go into why we deliver these math practices the way we do. And these are why I'm going over these in such a kind of in-depth kind of way. There's a natural connection between the operation of addition and subtraction because of the connection between joining and separating process, or the part-part-whole concept. All right, when we're talking about that part-part-whole concept, if we join 3 cubes to a set of 2 cubes to form a new set with a total of 5 cubes, it also makes sense that if we take a set of 5 cubes and take out 2 cubes, we will have 3 cubes remaining. Fact families highlight this connection, and that, for those of us who have that math sense and we know how to join and separate and compose and decompose, that seems very basic, but that is for our kinders and our 1s and our 2s, those are some very difficult concepts for those little ones. Now the key questions when relating to +1 and +2, because the questions that I had posted for chapter 1, great comments, by the way, for those of you who had posted. For this one, just taking 3 or 4 of these questions and asking and then submitting that for your assignment this time, that's all we're going to be asking you to do this time. But like when you ask a student, when you add 1, how do you know what the sum will be? And then they explain their thinking behind that. That to me is just I would love to be a fly on the wall to hear what your kids have to say about that. And when you add 2, how do you know what the sum will be? And explain your thinking, please, because how they're thinking that and what they say, especially if you hold up a number line and you say, okay, from this number, if you add 1, how do you know what the sum will be? And they tell you the reason behind that. And then if you look, if you move down to here to see what is 30 plus 1, explain how you know, then you can do a very quick formative assessment before you even start any activities to find out, does somebody already have that concept of, well, it's just the next number on the number line. But that's going to be, and I'll post it in Edmodo, but that will be the actual assignment itself, is to take 3 or 4 of those questions and ask them and then post the responses that you get from them. All right, the literature connections that we have in this book are, to me, just wonderful. This literature connection is for +1, +2 is mouse count. And when we use a literature connection, students are able to take that abstract idea of numbers and put it to a context that makes sense to them. And literature provides an engaging context in order for us to make the study of math facts just easier for kids to grasp and work with. So this is a cute book, and it's one by Ellen Walsh, and it's 10 clever little mice that escape a greedy snake that is planning to eat them for dinner. And the story sets a context for exploring counting on as a strategy of adding 1 or 2. And you would do all the normal things you do, when you're, sorry about that, going back to the slide, when you're doing the reading, you're going to show them the book and have them make a prediction of what they think is going to happen in the story and all of those things that you normally do with the pre-reading. And then during the story, have them talk or count with you and do those things that, of course, you're going to read the book first, so you know what the book is about. So whatever skills you feel would be the best for you to work on with your kids during that time, whether it's predictions or pausing for them to say the numbers that you want them to say, or whatever comes next. And then at the end of the book, after reading the book, then there's a fun game you can play where you have mice in the jar, and you have them in plastic bags, and you have a bag that has 1, and you have a bag that has 2, and a bag that has 3 and 4, 5, 6, 7, 8, 9, 10, like you see on the chart here. And I don't know which side, on the side of the screen where it says mice in a jar, they have a page that they can work on, and whichever bag they get, if they got bag B, that has 3 mice in it. And then they will see that they added 1 mouse to their bag that had 3 mice. So now they know they have 4. And they do a pictorial representation of that. So there's mice in the bag, and they count out 3 mice, and then they see that they add 1 more mouse to it. And then they do that pictorial representation of it. They do the numeric representation of it. So they have that concrete, pictorial, and now that abstract, so that gets them to through all levels. And then this chart that you see, you can have this chart in your classroom and then start asking these other questions. What do you notice about the different number sentences on our chart? Do you notice any patterns as you look across the rows? So when you're looking across, okay, so the number of mice in the bag, there's 1 mouse in the bag. 1 plus 1 is 2. So now you go across to the +2, and 1 plus 2 is 3. You go to that next line and ask them to explore what can they tell you that they see. And when they see 2, 2, 1, 3, and then 2, 2, 4, when they start seeing those patterns, that's going to be a great conversation that's going to be had in your classroom, because those patterns are going to make it just come alive for them. Okay, do you notice any patterns as you look down the columns? And when they notice those patterns going down the columns, and some of the patterns they might notice are that all of the answers are 1 more than the number of mice in the bag in the first column. All of the answers are 2 more than the number of mice in the bag in the first column. And that may seem very easy, but if they notice that pattern, That's a really, really good pattern to notice. So those are a couple of activities that can go along with the literature connection in the +1 and the +2. Okay, and then the next step that goes in the book, that was the literature connection. And then as students begin to explore the math fact strategies, it's important to provide experiences in which the students visualize the facts using a concrete model. They're required to move from concrete to visual experiences to symbolic representation of the facts and have opportunities to discuss their insights about patterns, numbers, and properties. Number strips, enlarged vision of number lines, are an ideal model for exploring +1 and +2. What you see on the left-hand side of your screen are the 0 through 12 desk size number strips, and then the questions that are on the right side of your screen, and I'm going to block that bottom question, I'm sorry about that. Darren took 5 bites of an apple, so over here you could land on the 5, and you could land on the 5, and being on the 5, and then she took one more bite. How many bites did she take? So then they would move their counter over to 6, so that they would move one more. All right, Kevin put 7 rocks in the back of his wagon. Then he put 2 more rocks. So they would take their counter off, and then they would go back and they would put it on 7 and then move it 2 spaces so that it moved over to his wagon. And you can go through all of those questions. Those are going to stay there for you. Okay, so that's just one of those, that's just one activity that you can do with an enlarged number line, number strips for kids to use. Exploring the commutative property. Now, when we're with manipulatives, you definitely want to practice that property with manipulatives, because if we don't practice with manipulatives, we're asking kids to utilize an abstract concept, and that abstract concept does not get deepened unless they have touched things and moved things and manipulatives and seen how it works. So the big idea of addition is that the order of addends does not affect the sum. And students are memorizing half as many facts if they understand the commutative property. Plus, you can suggest that they start with that larger addend and then +1 and +2. And it's going to sound repetitive because I'm going to say it again and again. That commutative property, start with that larger addend and then add the 1 or the 2. And it doesn't matter which one comes first. It doesn't matter which one comes first. It doesn't matter. So, and then like in this example of a writing assignment, I do not agree with Jimmy because 3 + 2 and 2 + 3 are just switched around. They both equal 5. So there was justification for someone who said, no, they weren't the same. So he was going in there and he wrote about why he didn't agree with someone, which I think is fantastic. All right, building automaticity. Why do we want to build automaticity for kids? Well, it goes back to that literacy piece. We want to make sure kids have fluency within reading. That's been something that we have stressed for years and years and years. And it seems that that hasn't transferred over to math, but it's something that needs to transfer over to math, because if we have automaticity in math, we have fluency in math, and that automaticity lends to fluency, fluency lends to comprehension. When we have automaticity in language arts, we have fluency. When we have fluency, we have comprehension at a higher rate. Students need to have been engaged in a variety of activities to understand 1 more and 2 more. Now, you have to have repeated opportunities to practice the facts. They have to be able to do them again and again and again. So using targeted practice, we will be focusing on building automaticity. The practice itself, it can be short in duration. It can be anywhere from 5 to 15 minutes during the day. But the thing is, it needs to be a part of every day in the math classroom. And the daily routine, there needs to be something that is working on doing that automaticity piece. When you think about, okay, how is that going to happen? Games. When what I've done on this slide right here is I have embedded each of the grade levels website because Michael walked you through a little bit of NCDPI, and I have put a direct link to each of the website game websites where you can go in and download the games from NCDPI, and I like to make them on cardstock and then put them in a big envelope, and you can either run them through a laminator or whatever in the big envelope, and then you can write on the envelope who is in that game center that day, and you can write the names on there and dry erase or whatever you want to. But those games are imperative for helping with that automaticity. It helps so much, and they have several games for each standard that we're required to teach, so that works out really well. All right, now we're going to move to the connecting to subtraction. Once students develop oh, I misspelled on that slide, I'm sorry, an understanding of +1 and +2 facts, take every opportunity to talk about the connection between the addition and the subtraction facts, and exploring the -1 and -2 facts, or +1, +2, 1 less, 2 less facts, and because there's a natural connection there. Now you're going to revisit, for this chapter it says that you revisit mouse count, and when you revisit this story, you're going to be in there about the escaping from the jar, because the story ended with 10 mice in the jar, and you're going to go back in there, and at the end of the story the jar was filled with 10 mice, and what if one mouse escaped? How many mice would still be in the jar? What is 1 less than 10? So you can set up several scenarios that way, which I think was really nice. You always want to use manipulatives. Again, manipulatives. You want to make sure kids have that hands-on experience. If you don't have the store-bought pretties, that's okay. Tear up paper. Whatever you need to do to get some manipulatives. That's anything that they can get their hands on so that they can move stuff around. That's the best way to go. Now the connection that they're making, the literature connection they're making here, is great for making predictions. In Counting Crocodiles, throughout this story, the students are going to be able to make connections, and they're going to be able to make predictions. In this book, they count from 1 to 10 and from backwards from 10 to 1. And the suggestion for this one is you do the predictability, but don't read the last 2 pages. Is this the one? No, that's the rabbit book. Sorry. In this one, the animals, you want to come up with have them brainstorm some animals, and you write down a list of animals, and then you model a story for them. And let's say you want some giraffes. So you choose giraffes or you choose bears, and let's say giraffes. And the giraffes, you model the story of the giraffes going to eat leaves by the trees. And one giraffe goes away and to drink water. And then you draw that picture for them, so that, like with what you see right here on the screen about the lions, there were 3 lions on the rock, and 2 lions went to hunt. How many lions were left on the rock? And then you write that sentence, that number sentence, to match the story. This is a very fun way to do that. And if you wanted to upload a story that you did with your kids, or some stories that your kids did, Michael and I would love to see, what your kids do. That would be fantastic. That's not going to be a requirement, but if you want to, get to our geek side, that would be a great way to do that. Now, for adding 0, +1 and +2, and we're into chapter 3 now. That was the end of. Let me make sure I'm right. Yes. Sorry. +1 and +2 and -1, -2 is how we started our math focus in chapter 2, and then we got through chapter 2, And then now we're into chapter 3. Now the focus allows students to gain a knowledge and comfort level with math facts that will help them understand the adding zero concept. The adding zero concept truly is a difficult concept. When I first started teaching kindergarten, I was like, why aren't you getting it? It's nothing. It literally is nothing. Nothing. But the more I did research and the more I did with kids and the more I understood why it was so difficult, that helped me put parts together to help them. The zero property of addition, because these are the big ideas right here. The zero property of addition tells us that zero added to any number results in a sum that is the original quantity. And again, are we going to expect a kindergartner or a first grader, or even a second grader to regurgitate that test? No, we're not. But what we do want to do is we want to make sure that what we are telling them is that when you add zero to any number that you have, you're going to have that same number. But we want to make sure they say original quantity at some point. You want to make sure they have those words. The order of the addends does not change the sum. And again, what is that called? We could say it all together. The commutative property. Addition is a joining or part-whole process. Now there's a couple of ways to look at part-whole, and I've done this a couple of times in the practicing, and I've put them in a place where I can't find them. Okay, oh, they're right here. Okay, so the part-whole process, and I'm trying to get the glare off of them. There it is. All right, we have these part-whole cards. I have them where they're already filled in. So when I'm asking a student to tell me what would go into this part, and then my next question would be, how did you determine that? Well, their thinking is what I want to know, because if they're going from 11 down to 7 and they're taking a, from here to here thought process, that's one kind of thinking. If they're going from 7 up to 11, that's another kind of thinking, and I want to know their process. Truly understanding their process is huge. Addition is a joining of the part-whole process. That's why I wanted to show you the part-whole card. And then subtraction, again, is a separate or a compare process. Separate or compare process. The zero property of addition tells us that zero added to any number results in a sum that is the original quantity. All right, that seems like a whole great big long wow. All right, and it is. An understanding of zero and the ways in which it impacts addition and subtraction equations is important. Adding zero to a quantity does not change the quantity. We all know that, but that is a very difficult concept for kids to get, especially when they're just beginning their number sense world. Subtracting zero from a quantity does not change that quantity. Subtracting any number from itself results in zero. Armed with these understandings, zero facts are quite simple to remember. Once they get them, they got them. That's the best part of this, is once they get them, they got them. The order to the addends does not change the sum. Again, what is that? We've said it a few times. Yep, commutative property. So addition is a joining of part-whole process. If one addend is zero, then nothing is being added or joined. The joining process does not increase the quantity. The same way that no one part is zero, then the other part must be equal to the whole. Subtraction is a separate or compare process. If nothing is being separated from a set, the quantity of the set remains the same. If you compare the quantity in a set to zero, the difference will always be the quantity within the set. If you separate or remove the quantity of a whole set from the set, you will have nothing remaining. So if you take all the apples out, you got nothing. If you don't take any apples out, you got the same thing. All right, key questions. Now this is like that other page with the key questions, but I'm not going to have you ask this because we're posting this on Thursday. I wanted to give you that time to ask those other questions, so you don't have to pose the 0 questions, because it's going to take you a little time to do both of these chapters. Okay, but asking these questions at some point in time would be very good. Okay, when you add 0, what happens to the sum? Why? And that's a great question, because if they can answer that, then moving forward is a good option. Does the order of the addends affect the sum? Give examples to justify your thinking. And you can see the rest of those questions. You can pause the video so that you can read through those, and you don't have to, I won't read through every one of those for you. All right, the literature connection for this one is a very cute story. It's Gray Rabbits 1, 2, 3. In this book, a rabbit finds some clay and creates a variety of animal friends, and before he falls asleep. And spoiler alert, he does fall asleep. The 0 is an add-in in the book throughout the whole book. And then the before reading would be everything you do for prediction, and what you do for reading. Look at the title, who do you think the character is going to be, all of the things you would do during that. And then during the reading, you can pause to see if the kids can understand what the numbers are going to be. And then, but this is the book where you don't want to read the last 2 pages, because he is going to fall asleep. And then after you do the recording sheet of how many animals were in there. Okay, so you record the number of animals on their sheet. And this one, you can hand out maybe clipboards, or do this whole class where they have the sheet at their desk, and how many animals did he make? Because the rabbit is actually making them out of clay. So for the worm, he made 1 worm, and then he made 2 toucans, and he made 3 bears, and he made 4 dogs, and he made 5 frogs. So, and then you read the last 2 pages in order for them to complete the number sentence, because he made 1 worm, but then he fell asleep. So how many more worms did he make? None. 0. Okay, so he made 0 worms. How many worms do he have? So you can see how you would finish that worksheet with them. And then you can talk about the number sentences and how they connect to the book. So to me, this would be just a really fun activity to do in your classroom. Now, this is going to just about wrap up our time, and I know it is a very short amount of time compared to what Michael had. This is the first time I'm recording, so I know I talked fast, and I will make sure that the next time I don't talk quite as fast. The importance of movement. This is something that I do know research has shown that the movement of your students can help take things from not being remembered to being remembered, from short-term memory to long-term memory. Okay, and when you focus on movement during your math lessons, students will have muscle memory for it, which is a great resource for them in their tool belt of things that they can pull on, but it gives them that visual, physical thing that goes along with every other tool you're giving them. So, for example, the example I have here on the slide, 5 boys are in the math center. Okay, you go, you go, you go, you go, you go. So you have 5 boys in the math center, and 0 girls are, join them in the math center. How many kids are in the math center now? And you go over and you count how many children are in the math center. Or you have them, you have the boys come back to their seats, and you say, okay, we're going to jump 5 times. Now we're going to snap 0 times. How many times did we move? And it's 5 times. So any kind of movement that you can work into a story problem that lends itself well to a story problem, you want to make sure you can work that into your day as well, because that does help with them recalling all of that information that we're giving them. So I want to thank you for your time, and again, the assignment for this time is to go back to that slide 10 and make sure that you answer some of those 3 or more of those questions and post your responses on Edmodo. And this will be on Edmodo today, Thursday. And if you have any questions, comments, or concerns, myself and Michael's email is right there on the screen. And I thank you for your time. And I will be covering chapter 4 and 5 this next week, and I look forward to seeing you then. Talk to you soon.